We haven't talked about our homework 2, so we are going to look at homework 2 first, and then when we start looking at the software, okay, the R part. Jenny, is she here? Jenny, plus, here. Harrison, yes, thank you. Joseph, yes. Thank you. Ziyu.
I corrected my answers, but I forgot to correct my total. So I corrected. I removed the parts that I needed to.
Right.
Just 2 minor
June Pearson.
issues.
John May.
Whatever.
I may gag it out.
Andrew Fett. Zhang Yu.
Yeah.
Zhang Yu.
Okay.
Nice. Congrats.
Song Yuchen.
I don't care anymore. As with the B, I don't care about the B. I'm done with coursework.
Well, I'm the same way. This is my last graded coursework at a 3.8. I'm not worried about it. I don't care.
And I still have one student's homework 1. Okay, you didn't put your name here. You got a 10. If you didn't receive your graded homework 1, please let me know. Did y'all got your graded homework 1? Okay, so students here.
Can I trade that in
Jenny
for my
Press?
grade?
What?
Can I trade that in for my homework 1 grade?
That's a good idea. Jenny Press, she's not here. Okay. Zhang Yu is not here. Jia Qi is not here. Okay.
Did you hear my email that I sent you for the my homework too?
Yeah.
Did you already get that? For homework
You,
two?
you didn't get your graded homework.
No, because I sent you a picture instead because I forgot it that day.
Oh, that's okay. I will look at it later.
Okay.
Yeah, yeah.
I just want to make sure you got it.
Okay, so okay, so actually, I want to ask the student to come here to talk about her homework, but she's not here. So, let me just show her solution to you. She didn't get 10 points, but I really like the way she showed the path. Okay, although yeah, she missed some terms for one component, but still I like the way she just showed the path. Okay, so originally I want to invite her to do the explanation, but she's not here, so I will just talk about her work here. So homework 2, we are going to use 2 methods. The first one is the choosing method to get the covariance matrix of WXY. Okay, so this part is given, so W part is given, so and WY, so starting from here to Y. So always remember, we're gonna starting from the dependent variable, and then goes back to the other variable to W here. And here we have one double-headed arrow. So C times sigma W squared. Okay, that is one component. We can also use this tab. Okay, so always remember, for each component, you're gonna use one and at most one double-headed arrow. Before the arrow, it's reverse original direction. Okay, there's a single-headed arrow. After the double-headed arrow, then it follows the correct direction of the single-headed arrow. Okay, so we have the other path from Y to X to W and stop here. So B times A and times the variance of the W. So this is the other component. That's it. We don't have any component to calculate the covariance between W and Y. And W and X, W here, X here, always. This is okay from W to X. So start from X, a dependent variable here, and then goes back to W. So this is one way. Okay, A times the variance of W, and that's it. Because you cannot use this path. This path, if you use this path, the direction is not correct because you have to goes back. So, but if you use this path, it goes forward to Y. It's not allowed. Okay, so you have to goes back to the other variable. And W and the X and the Y. Okay, so look at X and the Y here. X goes to Y. So Y is a dependent variable among these two. X is kind of like an independent variable. So you're gonna start Y, and then the very obvious components starting Y goes back to X. Oh yeah, that's better. Thank you. Yeah, goes back to X and B times, and X goes up to V and comes back. So we have V times 1, and the variance of V goes back to X. Okay, let me show. So this is one component starting from here, goes to X. And then you have to use one double-headed arrow here. Okay, this is one double-headed, and stop here. This is one component, B, V squared. And also you can, starting from Y, stop at X. So you can use this path because before the double-headed arrow, you can reverse the direction. After the double-headed arrow, you're gonna follow the direction. So this path is totally fine. So C times variance of W, and then goes to X. So this is the this should be the blue one. Okay, so this path is also okay. And then we're gonna use this one, goes back to W and go back to X. Okay, so starting from Y, goes to X. The first component, we just stop here. Okay, we just use this path. But here we can also, against the direction of the arrow, and use this double-headed arrow. And then follow the direction, stop here. So B times A, and the variance of W, and goes back to X. So A twice. And you use one double-headed arrow here. Okay. So we have 3 components: the red one, the blue one, yeah, the indigo one. So we have 3 components for these covariance between X and Y. And for X, you're gonna use this component. Okay, so 1 times the variance of V and times 1, and stop here. And actually we have another one because here we have this test, okay, goes against the direction, reverse to W, and times the variance of W, and goes back to X. So this is another possible component. So we have this A times the variance of W and times A. But you cannot use this component because if you use this component, the direction is not correct. The first step, you have to kind of like against the direction of the single-headed arrow. So you cannot follow this way, okay? So this is correct. But after you have one double-headed arrow, you can follow the 2 directions. So this is correct. So for variance of X, so you have 2 components here. That's it. Yeah, so for the component of variance of Y, she missed some points because she forgot to include some other component because this one is not easy. So we have so many components. So starting from Y, we're gonna stop at 1. So this is the easiest one. 1 times the variance of E and times 1. So stop here. So this is one component. And then we can use this component, okay. The X component, we can go back to X and use the variance of V, and then goes back to Y. So V times 1, variance of V, 1 times B. So this is one loop, goes back to. And we have this path. Okay, starting from Y, goes back to X, and then goes back to W. And then use a double-headed arrow here, the variance of W, and it goes back, okay, follow the same direction, okay, A, B. So we have B times A, variance of W, sigma W times A times B, okay. And we can also use this path, okay, starting from Y, goes to W, okay, again, against the direction, and the variance of W, and then goes back to Y. So it's C times the variance of W times C. And I think she just stop here, but actually we have, yeah, we have this circle and this circle. Okay, you can start from Y, goes to, and again, the arrow goes to X, and then goes to W, and use a double-headed arrow, follow the direction of C, stopped at Y. That's one component, and you can also use this reverse loop. Okay, start from this one and end here. So that's why she missed the 2 components here. She didn't get the full score. But the way, by using different color to show different path, this way is I really like the path diagram here. Yeah. And the second part is about the matrix calculation. So we have the very simple case, the simplified path diagram. So what is the F matrix? Based on this, we only have 2 variables, okay? And we have the simplified version. So no residual error involved. So we have X, Y here. So this is identity matrix. But how about A, the single-headed arrow? So all of these tell us the single-headed arrow. So from X to Y, we have beta here. So from X, Y, we have beta here, and all the others are 0, 0. So this is A. This is A matrix. And for S, we're gonna save all the double-headed arrow. So double-headed arrow for X, we have sigma square. So let's look at the path diagram here. Yeah, so for X, we have the double-headed arrow sigma X squared. For Y, we have double-headed arrow sigma E squared. That's it, double-headed arrow, and the other parts are 0. So we have 3 matrices ready. And then by using this formula to calculate the covariance matrix. So because F is identity matrix, you can just ignore it because identity matrix times anything just equals the original matrix. So you can just take out the 3 matrix out and do the calculation. So identity matrix minus A, this is A matrix. So that's a residual matrix. Then you're gonna calculate the inverse of this one, okay? And after you do the calculation, this is the inverse. And the rest part is the inverse of the transpose, okay? Oh, this is the inverse, okay? Inverse times the S, and then she got this one. And then times the transpose of this one. And finally, she got the final answer. Okay. Yeah, that's it. That's it. So for some homework, starting from the matrix, okay, I noticed that some matrix are not correct. But you do the calculation, eventually you got the correct answer. So there's a jump. Okay, I didn't follow the logic because I was trying to follow the way you did the calculation. It's not correct. So I didn't give you a full score if you have some mistakes in the previous, although the last step is correct. But because some mistakes during your calculation, I didn't give you full credit. Okay. And some students just didn't get the final correct answer because some mistakes in the calculation. Okay. Yeah, for the first part, I said, okay, if you didn't give me the path, if you didn't show me the path, I will not give you the full credit. So some students just copied the answer from homework 1 and show it. So I didn't give you full credit. So you have to show me the path, the order. The order is very important, okay? Even the order shows a different path. Okay, so that's for our homework 2. And again, if you are not satisfied with your scores, then you can just let me know, and I will give you a second chance. Maybe okay, you can just correct them and resubmit it to me. Okay, that's homework 2, and then we are going to continue the lab. The R part. So last class we did we had a very brief review of the R language, how to install R, how to do the basic operations, including vectors, matrix, and reading data, import data into R, and some other functions, for example, linear model, linear regression. And yeah, also we introduced a concept called packages. There are a lot of packages in R. We're gonna install those packages and use library to attach this package, and then use the function inside that package. Okay. So today we're gonna use a very special package in R called SEM. So just follow the previous procedure. We're gonna first, okay, if you haven't installed that package into your R, you have to install the package. This is a name, and then use the library to attach that to active or to activate that package. And there are 2 ways to install package. You can use a command like this in R, or you can use okay, you have the R Studio. We have the right panel, the bottom part. There's a lot of tabs. One tab is called package. Then click install. And then just manually input the name on SEM, and automatically this will install that package for you. So in this package, it will provide us the RAM matrix. Remember I said that the RAM matrix, the method by using the RAM matrix is by default using all this SEM software. So it will report the F matrix, S matrix, but they use different name. In SEM, the F is called J. Okay, so in that package, J matrix just a field matrix in our lectures. And S is called P. Okay, if you type in P, I will show you. Okay, if you type in the P matrix, it also automatically return the symmetric matrix. Okay. Okay, so we have 4 steps for data analysis. The first step, data preparation. You have to make your data ready. You're gonna input your data manually or import the data from other software, make your data ready, data preparation. And then you have 2 matrices. One is called the sample-based covariance matrix X. Okay, the other one is called a model-based covariance matrix capital sigma. So this step to prepare the sample covariance matrix, if you have your data ready, you can just immediately use a covariance matrix to calculate that matrix. If you don't have your data, so for example, if we just want to do the demonstration of the S, you can create the matrix like this. Suppose this is our sample-based covariance matrix. By creating a matrix, this is the variance of X, okay, the covariance between X and Y, the variance of Y. So we created a sample-based covariance matrix called S. 2 rows, 2 columns, and then row names, column names. That's the S. And then we're gonna calculate the sigma. Sigma, you don't need to calculate it by yourself, so the software will help us to do that. But you have to tell your software, what is your model? What is your SEM model? And then in SEM package, there's a function called the specify model. Okay, specify model. This is a built-in function inside that package. After you use the library, this function will be ready for you to apply. So specify model, parentheses, and inside this part is your model. And after you enter all these commands, you have to use pound sign to finish that function. Otherwise, the software will just keep asking you, what's the next command? So you have to use a pound sign to finish all of these commands. You just included it in the specified model. Okay, so we're gonna explain this part in the next slides. This tells us the path diagram here. Okay, so suppose you have the simple linear regression, then we're gonna translate this path diagram to the R code here. This is for the capital sigma. And then finally, we're gonna estimate our model. And there's a function called SEM, okay? This is a function name. And all of these are included in the SEM package, okay, SEM. And then you're gonna give some information. Red, this is a model. This is a model you specify here by using the specify model function. S is specified here. S, okay, so model-based covariance matrix, sample-based covariance matrix, both are important part for our SEM. Okay, sample size. Question, yeah.
So in step 3, we're basically doing exactly what we did for homework 2 on where I'm telling R what the paths are that
Yeah.
we're looking at.
Based on different model here, you're gonna change, you're gonna modify some
So
lines here.
this
I
is
will-
the application of homework 2,
Yeah,
part 1.
yeah. So yeah, I will tell you what's the name, what's the function of these, and
Sure.
what's the meaning of these positions, what is on A. Yeah, so basically we have 4 steps. Make your data ready, the first step, and then you're gonna make sure you have 2 matrices. So sample covariance matrix and the model covariance matrix. Model covariance matrix is by using this function, the software automatically calculate for you. And the last step, we're gonna do the estimation. And also look at this, okay, this component, the sample size is also important. You need to know the sample size for this function. Okay, so we mentioned this function, specify model. So this function gonna create a model for us in the software, okay, in the package. And we have 3 parts. Look at here, okay, we have three parts. The first component here, okay, the second component here, the third component. So what does that mean? So what are these components? The first component, arrow specification. There's a double-headed arrow or a single-headed arrow. There's some arrows. The second part is parameter name. You're gonna give a name for your parameter and some value, okay, some value. So let's look at these entries one by one. Arrow specification. Yeah, let's look at this example. This is our example. Sometimes we have single-headed arrow, sometimes we have double-headed arrow. Look at this part. Yeah, so if we have single-headed arrow, for example, A goes to B or A goes to B, okay, the position doesn't matter, but the final definition is A goes to B. Okay, so it's A in the left side or the right side, it doesn't matter. But you have to show that the direction is from A to B. Then that means there's a regression, there's an independent variable, there's a dependent variable, okay. So this is a show that we have a coefficient needed to be estimated. A or B or C or beta, there's a coefficient for that path. We needed to estimate that part, okay. And if you have double-headed arrow, for example, in this case, and here we have the same variables, A and A, that means I'm gonna calculate the variance of A, double-headed arrow, the same name. And sometimes we have double-headed arrow, but different names of this, okay, these 2 variables. That means I'm gonna calculate the covariate between these 2 variables. Okay, variance of A here, covariance between A and B. Here, this is a coefficient from A to B. All of these are parameters. We are going to estimate those parameters. Yeah, so in this case, okay, A and B are variable names in the model. If a name does not correspond to an observed variable, then assumes there's a latent variable. Yeah, we will show the latent variable later on. But so far, we just focus on the observed variables. Okay. So when we have some different pattern, okay, we may use different form. For example, here we don't have any space here, but here we have 2 hyphens. Okay, here we only have 1 hyphen, and here we don't have any hyphen. Or you can put a lot of space between A and B. It doesn't matter. So this part is very flexible. It only tells the R. You need to tell R from which variable to which variable. Okay, that's for the first part. Look at this case. So in this path diagram, we have A goes to X goes to Y. So we have X that goes to Y. We want to know the coefficient of this path. And here, variance of X. Okay, X double-headed X. So I'm gonna estimate the variance of X. And here, Y. I'm gonna estimate the variance of the residual of Y. Here, this is not the direct Y, because this is a simplified version. Remember that I said, okay, in the computer softwares, they use a simplified RAM, not the original RAM. So here we ignore the residual part. In the traditional path diagram, there's an E, and we have 1 goes to E and the variance of E. But by using the simplified version, so Y goes to Y. That is the variance of error of the Y, because Y is a dependent variable here. Yeah, you have a question?
So on step 3, we're doing 2 separate things here because we're showing the path X to Y, and then you have the comma, and then you actually have the variable of what that coefficient is.
Yeah.
Okay.
So yeah, we just explained the first part.
Right.
Next, we're gonna show this component. That is a variable name. Yeah. So let's move to the second part.
Sorry, I wasn't trying to get ahead. I was trying to follow you.
Thank you. Parameter names. So the second position, you have to give a name for that parameter, either coefficient or variance or covariance or other parameters. Yeah. For example, we have B. Okay, for example, if you have the previous example, we have B. The coefficient is named B. And the coefficient for, this is not coefficient, the variance of X is named SX. The variance of the residual of Y is named SC. Okay, it's just name. You have to give a name.
So is that S for sigma?
Okay, yeah, you can think about that. Or you can just give it, the name doesn't matter. So you can just give X or something like that. X squared. Yeah.
Yes, ma'am.
So like the NA where the value is, that means like you
Oh,
want to
that's
estimate that.
Great question. That's the third component. We just explained that this second
We're on
position.
the ball today.
Yeah, we haven't talked about the third component. Yeah, the third position. That means actually it's a starting value. Okay, because we're gonna do the estimation. Remember that we talk about estimation. We have some we have some procedures. Maximum likelihood or other procedures. We give an initial value, starting values, and then do iterative calculation, and finally they get a converge result. So that position actually is for starting values, but here I didn't give any starting values. So I give NA. NA is for, okay, I don't want to give any number here. So that means the system provides the starting values for us. You don't need to provide those initial guess. So the system will just give you some initial guess. And then eventually they will converge to the true estimate, because this is a really simple model, but for some complicated model, because for example, in your own research, for example, in your maybe your class project, if the model does not converge, you might have some error message. Then you're gonna try to give some initial values to put the solutions within some range. Okay, initial values means, okay, you can give a starting value, tell the algorithm algorithm, okay, you're gonna start here and do the estimation. Sometimes maybe they choose a very wild starting value, then maybe convert it to other places.
Would that be like a weighted value?
No, it's
No?
not weighted value. It's starting value. So we have iterative procedures. The first step, go give the starting values, and then they trying to maximize the likelihood function. And then we have some first step result of the estimate of the result. And then you that one continue doing the procedure, trying to get the likelihood function, trying to maximize that. And we have second step. So initially, yeah, so eventually we have many iterations, and finally we converge to, I said converge. So what does that mean, converge? So we have the previous step estimate, and we have next steps estimate. If these two sets of estimate is really close to each other, we can set up a threshold, for example, 0.0001. If the difference is less than that value, we can say that, okay, it's converged, because every time after they do the iteration, it's really close to the previous estimate. We can think that it's already converged.
Okay.
But sometimes it's diverged. Okay, so every time they would just jump around, they cannot get a very close result. And then we have debug procedure. Okay, how are we going to fix those problems? One very important technique is just trying to give a very reasonable starting values. Then the machine will just kind of like continue the iteration within that range. But that's another topic. Yeah, at the end of this semester, I will show you how to do this. Yeah.
Thank you.
But yeah. But anyway, these positions for starting values, but usually we do not need to give those numbers. It's just an A. The system provided the starting values. Okay. But sometimes we give an, okay, that's next step. Okay, just finish this slide. Okay, we have some other details. And finally, the pound sign, again, is very, very important. You have to use a pound sign to end these lines, to finish these lines. And the SEM automatically know that, okay, that's the end of the model. Let's go to the next step. Okay. And the fourth step, estimate model. We are going to use the function SEM. And again, three part of information. The information of your model, your sample covariance matrix, and sample size. You're gonna provide this part of information, and then we do the estimation for you. This step is do the estimation. Okay, so we specify that the covariance matrix is the previous steps, and the sample size, you have to make sure you know the sample size. The model, you specified the model in the previous step. Okay. Okay, so that's our explanation of the part. So if you open the ELC, you can download. Let's try to open RStudio. RStudio. Okay, and we are going to open our file called regression SEM. Okay, so go to ELC and open the file regression.r. Okay, so if you haven't installed that package, you can just run this line. But if you have already installed that package, you don't need to do it at the same time. If you want to check, okay, go to the panel, the right panel here. Here we have some tabs. One is called package. Okay, so click the third tab, package. All of these are packages installed in your current computers. Okay, so you're gonna check if there's a package name called SEM. If you didn't find SEM, it seems that we restarted the computer, so I don't have any package here. So here we have another two sub tabs. So one is called install. So you can click install button here, and then it pops out a small window here. You can tell us the R package what is a package name. Okay, just type in SEM. And then click install, the button of install. You're gonna wait some minutes because there are a lot of like other packages related. So they will have to install all of the packages for you. So here there's a stop sign. Okay, stop sign. If it's red, that means okay, the system is running. You can just wait. And if it's done, okay, there's a no stop sign here. That means it's done. Okay, so you already installed the package, but that's not the end of story. You have to use library to activate this package or to attach this package. So you can highlight these command and oh. Package or failed. What does that mean? So let's check the SEM.
I had updates on mine. I just did.
Well, they should install as a newest version. What happened then? Still it's not here. So let
You
me,
may need to restart R. Close the whole thing and restart R.
the R is outdated.
No, it may just. Okay.
I cannot install the package here. Why? So it's fault. Do you have any error message?
Mine did fine, but it did say you have to restart it on my side.
Why?
I also got the same error message. Now
Oh,
I
you cannot use a.
Yes.
So here, can you check the SEM package here? If that is successfully installed, is done or not? It's
In
failed.
R console, it is okay, but in R Studio, no.
Oh, okay, then we can use R. So this is R Studio, but I think the R is also if it's ready, if it's installed, then there's a package name shown here. But I don't have the permission to install any software in this computer because I'm just a user. If I'm trying to install R, I don't think it's allowed.
No.
So let me, can I use this computer?
Sure.
Do you have any similar error message? Do you have your?
Mine? No,
yeah.
all mine went in. Fine. Get it in the home.
I should bring my own laptop so that I can use my laptop. But I have to use this computer here. So if I want to, I don't think I have the permission to
Probably not.
install R to this computer. Let me check if the OIT person is still working.
Thank you.
Crap, how long did it take you?
That's wrong.
I was like, you got your eights, everything. like you have.
So they,
So it's getting fancy.
right? So you know that, the agents should like, but
Yeah, I know. We're not- we're just-
yeah,
Yeah.
I get five at one.
Okay.
With the, like, something that, like, like, CD bitch.
Yeah.
I got it from there.
Yeah, looks like you got the spicy one too. I saw it
Mhm.
already.
And then I have the mushroom, or the, what is it? I put spinach, and I put more seaweed flakes on top of that. And I put some cheese.
Oh boy, I forgot cheese.
Oh my gosh, I see. This is really very plus.
That was really
Is
good.
there other
Really
reason
good.
for it?
Really.
Maybe you can post
I
it
guess
on
it must be
Medium.
Like a
And we
day.
use
Was
some
it
people
really
some
like
stuff.
a
I know,
day?
I needles just.
Literally, a plus, it'll be like for example, we're actually doing one line.
Yeah.
So do you have your own error message like that?
I had like this error message, like I had a longer one.
Oh, that's good, that's good, that's
Like
good.
these,
Let's go to the end of this package.
it was something like I had to combine everything, but I mean, eventually I did.
That's good, that's good. Yeah, you have library SEM done. So,
So I checked in SEM's update, this is the error, it's looking for this package that's not installed over here.
maybe I should update the R version here. It's R Studio and R. Where would you? We can just go to, I'm sorry. You can just go to the website. Yeah, here, okay, download, yeah. Let me see, download the R.
Try some things.
Oh, yeah, it's a photo, it's fine. Seriously.
See if we buy login.
Are you admin?
I have the administrative login, so I'm gonna try and see if that would work.
Try to make it that one.
Hey, I'm watching you guys do it. Yeah, you know, okay, we can start
That's
spring,
Mhm.
but like to start with a new project. Is it basically like starting another project?
Yeah.
Okay, because I feel like if it's something like drastically different, it's like, you know, you've done this before.
Mhm.
What does it feel like? It's the first time you've done it before.
It's basically an extension of because of my goal of to for semantic manifestation.
So it should work with
It's
this
about
login and then I can just, it's not,
Okay.
Yeah.
So, no, there's. Paper I did, I got lots of fancy days.
Oh, and we uploaded crash report.
So first part, the first one is first chart is right there. The second chart one is how to use the perception and what the perception of in practice.
Okay.
And the third chart is dialogue.
Yeah.
Hours, I calculated the hours would be this is both what we do. So by hours. Don't share some. But if you want to do that, you don't have to. On the you should write left here.
Yeah, it seems,
If it works.
but not yet. Let's just wait. Yeah, let's wait.
From the Western world.
That's good.
So like that's okay. So yeah. That's
Right. Right.
in my head, I think this, how long is it to put, station? She said it was too long, and that it was fine. Yes, because you I can't. I don't know.
Yeah, it's here.
Another name school.
It going up?
Oh, I need to finish it, but it's not there.
Maybe you can help us to start.
Okay.
Yeah.
Is it basically just a good?
I'll send it back, send it back to that.
Gotcha.
Yeah.
This is the one that we're trying to tell us.
Mhm.
And then we're talking about Dr. Lewis.
Yeah, this was the one here. Oh, this actually.
Oh, so it's different.
Mhm.
So we can choose any one.
Let us continue. Excuse me, so should I log out your account or?
You can, or you can just keep it, it's up to you.
Okay, so after
Just at the
the,
end of the night. you just have
okay,
to-
yeah, after this class, I will log out your,
Okay, that's fine.
yeah, thank you.
Oh, okay, yeah.
I mean, crowd is like perfect.
Yeah, she should.
Right.
Mhm.
Oh, like 280. I might have been 280.
You do it.
Or- Oh, I think that. The t-test too. Yeah. So if we're gonna assess it, we have to assess it. It's a lot of assessments.
Okay, right.
This one. Sorry, I did it, I just wanted to 300, but yeah, I guess 280 is like that would be.
Mhm. Yeah. ทีตัวหมด
Okay. So last time we failed to install the package called SEM because, okay, so because one package actually include a lot of like relevant package inside that one. And there's a package called the matrix. What is that, madam? Matrix matrix calculation, matrix CAL, something like that. They didn't install that package. So we tried many times and we didn't install the SEM. And then we manually choose the package. So we click the install and manually install the matrix calculator, matrix scale some package. And it seems now it's working, okay, because that the previous time, previously that package is missing. So they cannot do the matrix calculation. So after I run library SEM, no error message anymore. Okay, so this is just a warning message. That's okay. And okay, suppose we have our sample covariance matrix. S is 2, 1, 1, 2. We have 4 elements. Okay, so 2 is a variance of X, 1 is a covariance between X and Y, and 2 is a variance of Y. So suppose this is S, and the column name, row names, that means, okay, in that matrix, the column name is X and Y. So we have 2 vectors. The row name is X, Y. So we have 2 rows. It just shows that we have 2 by 2 matrix. The dimension is 2 by 2. And then we highlight this part and click around. So if you type in S here, okay, if you want to check the S sample covariance matrix, then you can just type S here. Then that's our assumed sample covariance matrix. So 2, 1, 1, 2 is here, 2 by 2 matrix. And then next step, we are going to specify our model. Here, specify model. This is a function name. And the parentheses, we have 3 parameters. We have B, which is a coefficient from X to Y. So we need to estimate B from X to Y. The name is B. Starting value, NA. I don't want to specify any starting value for this parameter estimation. The second parameter I want to estimate is the variance of X. Okay, so variance of X, X, double-headed X, and I name it as X. You can just name it S1 or S2 or any other VX, variance of X. It doesn't matter, okay, it's just a name. And the starting value, I don't want to put any starting value here. And then I'm gonna estimate the variance of the residual of the Y. So Y goes to Y, okay, it's double-headed arrow. I call it SE, the sigma error part. Of course, you can also name it S2 or VE or any other, yeah, whatever you want. And the starting value and A. And then end with a pound sign. So you can highlight this at the same time. For R, usually you can just run the line by line, but this is just a whole block. This is just a function, one block. Please highlight this part, choose this function together, and then click run. So finally, we have read all these 3 commands into R. Okay, 3 records. Read 3 records. So that's the 3rd step. Okay, the 4th step, we are going to use estimate SEM. So SEM is a function, and we have model here. SEM, we have 3 components. Okay, the first component is a model. The model is here. We call it a regression. This is a name. This is the name of the model. Okay, this is the name of model. The simple regression is called REG, and then the REG is a name should input here. This is a model part, sample covariance matrix part, sample size here. And also S is specified in the previous step. So we highlight this part and try to run the model estimation. And here, it didn't give you any result because you haven't asked them to print out the result. You can just ask R to print out the result by call the name of the result. Okay, just call the name here. So that's it. It's really simple output. We have coefficient of B estimated here, 0.5. Variance of X estimated as 2. Standard error, variance of the error of the Y, 1.5. So this is the 3 parameter estimate. We XR to do the estimation for 3 parameters, B, S, X, SE. And also we have the model chi-square value degrees freedom. We will talk about this later. Okay, how to calculate the degrees freedom, how to calculate the model chi-square value. We will talk about this later. And that's it. But this part, again, this is too simple. We don't have any additional information. Again, just like we reviewed in the previous week, we can use summary, ANOVA, or other names to look at the details. Okay. So for example, summary, the result. Here we have the standard errors, T ratios, Z here, this show the Z values, probabilities, and also we have some modified indexes, AIC, BIC. Yeah, again, we're gonna see the indexes, modified indexes later on. And normalize the residues. So let's just look at this table. Parameter estimates, we have 3 parameters, B, coefficient, SX, the variance of X, SE, the variance of E, and the point estimated here, okay, 0.5 to 1.5, standard errors, Z value is a ratio of these 2 numbers, probability. Look at this part, okay. This is called a scientific way to show the decimal points. Some number here, and we have E minus some number here. So what does that mean? So this means in order to correctly specify this number, you have to move the decimal point 9 positions ahead. So here we have E to -9. So we have -9 positions skipped. So that means that the number is really small, 0.00000 and 9. So this is almost 0. And the same thing here. So E, -12. So that means you have to move this decimal point 12 positions ahead to get the true p-value. So it's really, really tiny. Okay, same thing here. Okay, it's almost 0. So the p-value is almost 0. That's a summary of the estimate. And also you can check the, okay, so model 1 regression, this is a result. After we run the SEM analysis, all the results are saved here. So let's check what's inside this object. M1.regression. Okay, so the result, what's inside? So check by using names. Here, all of these results are stored in the model 1.regression. All of this information. So the results are saved here. So all of this shown by different names. And then let's look at the A matrix, J matrix. Okay, so we have 3 matrices. F matrix, A matrix, S matrix. In SEM, the software also provide you all of these matrices. Let's check. So the F, as I mentioned, the F is not called F in this package, it's called a J. Okay, this is J. And also A matrix is still called A here. And the S matrix is called a P in the SEM package. So let's try to look at F first. Okay, use $. As I mentioned, if you have a lot of components inside of one object, you can use $sign to specify that component only. So I want to know the result of this model 1.regression. There's a J matrix. J is a number, is one number. It's a filter matrix. So highlight this part and click around. It's just a identity matrix. Remember, it's filter matrix. Okay, so when just like our homework 2, it's a simplified version of RAM. The filter matrix F is just identity matrix. It shows here. Okay, this is just identity matrix. It's F matrix. And then let's look at A matrix. A matrix here. Okay, you again use the $sign A. That's it. Okay, this is our A matrix. In our homework 2, homework 2, do you remember the homework 2? What is simplified? Is it? Oh, it's here. The homework 2, the same model, and the A matrix is 0, 0, beta 0. Remember, this is our A matrix. Now we have estimate of beta. Beta, what is beta? In the previous, beta is 0.5. Remember that in the, here, it's okay. Here, beta is B, beta is B. Coefficient is 0.5. So this beta is 0.5. So this is our asymmetric matrix, 0, 0.5, 0. Okay, so that's it. This is our A matrix. It's just like this. It's just exactly the same one. Okay, 0, 0, 0, beta. The beta is our B, it's 0.5. Okay. Then we can also check the covariance matrix. S, okay. S is sigma x squared 0, 0, sigma e squared. Now we have those estimates. We have estimate of sigma x squared. We have estimate of residual part. So you can just replace these components. And finally, we have the, let's check. Okay, we have the P. P matrix. Okay, highlight P. And it's 2, 0, 0, 1.5. Because the variance of x is estimated, this one is estimated 2, okay? And the sigma e square is estimated 1.5. All of these are provided in the previous table. Okay, let's check. Here. So the variance of x, sigma x squared is 2.0, and sigma e squared, sx, the variance of the residual y is 1.5. So the S matrix is reported, let's see, reported here. Sigma x squared, sigma e squared, and this is beta, So we have F matrix ready, we have A matrix, we have S matrix, although it's called a P, okay, but it's the same as our X. All of these are provided in the results, okay. And when you check the names, there are some other information included. If you want to check each of them, that's totally fine. Okay, you can check. Yeah, so there are a lot of like covariance matrix. You can check coefficient. Yeah, question.
I keep getting an error message that the object is not found.
Did we say? I heard it, so you gotta start her.
Oh,
Like,
you
I
have to run the specified model. Did you run the specified model? You just run the S, but you haven't started the specified model. Go to the previous. Okay, you have to highlight the regression part. Highlight all of these. Yeah, and run. And then run SEM.
So I'm getting that.
And then check all of these. And then it's ready. Yeah, you can check. Yeah, check all of this. It's yeah, it's ready.
Thank
Yeah,
you.
you're welcome.
I was done.
So you can check, for example, variable names. You can just use dollar sign to see what's inside here. Then we have two variables. Inside of this model, we have X and Y, variable names, two variables. You can also check RAM, what's inside there. Okay. Then that's a RAM estimation. So we have 3 parameters. Parameters 1, 2, 3, starting values. Didn't specify any starting values in our model. So we have 3 parameters. So the heads, B is single-headed. So the number of heads 1 because we only use 1 head. S, X, and SE, we have double-headed arrows. So we have 2 double-headed arrows, 2 arrows. And from to, okay, from X to Y, okay, here, XS, from X to X, here, from Y to Y, 2 means Y, okay, 1 means X. So from X, from 1 to 2, that means from X to Y. So it just gives you the details of the red. And you can also check this one. This is a sample covariance matrix. Okay, in the red, in the SEM package, the S means the sample covariance matrix. Okay, and you can also check this coefficient here. Coefficient three parameters, and then maybe see here. Okay, so that's part of example of our homework 2. Yeah. So we have already talked about this. Yeah, so we have already covered this part. Now let's look at the degrees freedom here. In the beginning part, when you look at the result, chi-square value, okay, and df. What is df? Df is a degrees of freedom, 0. Why the degrees freedom 0? So let's look at this part. How to calculate the degrees freedom? So in order to calculate the degrees freedom, there's a formula. Okay, so before we introduce that formula, let me talk about some concepts. Parameter. We know the we know the name. We know the definition of parameter. Okay, just unknown quantities and model and the number of information. This is very important. What is number of information? Number of information.
It's
How
your
are we
N.
going to calculate this information? Calculate this number. Okay. So let's look at. Let's start from a very simple case. If we have one variable, okay, we suppose it follows a normal distribution. Okay. Normal distribution, we only have 2 parts of information, mean and the variance. Okay, we have mu and the sigma. And usually we make sure, we're trying to assume that the mean is 0. Okay. Then the variance is the information we want to need. Okay, so we only have mean and the variance. If we assume mean is 0, then we only need to use one piece of information, which is variance. But now if we have 2 variables, okay, so previously, I just give the case of p equals 1. We only have 1 variable. If we have 2 variables, suppose we have x and y, then in order to get the covariance of information of the covariance of x and y, you need to specify this 4x4 matrix. And this information is necessary. This is the variance of x. This is the covariance between x and y. This is the variance of y. So we need 3 pieces of information: variance of x, variance of y, covariance between x and y. So this is for 2 variables. Okay, when 2 variables, when p equals 1, when there's only 1 variable, then we only need to, suppose this is x, we only needed to know the variance of x because we assume the mean part is 0. The main focus of the SEM is the covariance part, variance and the covariance part. Now, how about p is 3? How about we have 3 parameters? So if we only have 1 parameter, 1 variable, we only need to use 1 piece of information. If we have 2 variables, we have 3 pieces of information, 3 pieces. But how about those 3? How many? What's the number? We have formula. Yes, we have formula to calculate that number. if P is 1, if there's only one variable, this is the formula, okay? P times P plus 1 divided by 2. P is 1, 1 times 1 plus 1, 2 divided by 2, it's 1. You only need, there's only one piece of information, okay? So when P is 2, you have 2 variables, X and Y, suppose. Then you need to know 3 pieces of information, okay? So we have P times P plus 1 divided by 2. 2 here times 3, 6 divided by 2, it's 3, okay? But when P is 3, what's the number of information? P times 4 divided by 2, it's 6, okay? So 6 pieces of information is ready if you have 3 variables.
Are we just solving for our n? N minus 1 would be our degrees of freedom.
Oh, that's different.
Okay.
That's different. Now we are talking about SEM, the number of information. Okay,
Sorry.
so which 3? Suppose we have X. Let me change it to another. 3 variables. Let's see. Suppose we have Y, X, Y, Z. Covariance matrix of these 3 variable will be 3 by 3. Okay. You definitely need to know the variance of X here, variance of Y here, variance of Z here, and the covariance between X and Y, and the covariance between X and Z, covariance between Y and Z. The other parts are redundant, okay? So here we have 6 pieces of information ready. If you have 3 variables. So all the number can be calculated by using this formula. When you change the number of P, the number of information will be different. So what is this number? This number tells us the information, the how much of the information is ready for you to use to estimate the parameters. Okay, this is available information for you. So by increasing the number of P, the number of information will increase. Now let's look at how to calculate the degrees of freedom. Once we know the number of information, the degrees of freedom is difference between 2 numbers, okay? The number of information and the number of parameters. So number of information is available for you. And then you have number of parameters. You want to try to estimate some parameters. The difference between these 2 is the degrees of freedom. So you have, so suppose you have 10 pieces of information here. You're trying to estimate, for example, you're trying to estimate the 4 parameters. So you use the 4 pieces of information. You still have 6 pieces of information left. So that's called the degrees of freedom. You can think about that way, okay? So the degrees freedom is calculated by using this formula. What is the first part? This part is called the number of information. This is just number of information, P times P plus 1 divided by 2. What is Q? Q is number of parameters in your model. This is available pieces of information. This is the information you're gonna use for estimating your model. So what's the difference is the degrees of freedom. This number tells you, okay, is that any available information to estimate more parameter or not? If it's 0, that means done. I cannot estimate more parameters because I have already used all number of information. If I have something left, I can still estimate more parameters. So this number tells us, okay, so do we have degrees of freedom or not? Okay. Let's do an exercise. Suppose here we have X, we have Y, and we have latent residual part. But the P is number of observed variables. Always remember, P is number of observed variables. In this case, how many? How many observed variables? What is the P number here? 2, yeah, don't say 3. Because P is number of observed variables, not all variables. So P is 2 here. Then let me ask you, what is the number of information for this model? When P is 2, what is the number of information? Three.
Oh, sorry. No, I read the number wrong, sorry.
Yeah, P times P plus 1 divided by 2. So 2 times 3 divided by 2. We have 3. How many parameters? How many parameters we are going to estimate in that model? We have V, coefficient B. We have variance of X. We have variance of the error part of the Y. We have 3. 3 is the number of information. 3 is the number of parameters. What is the degrees freedom for this model? What is the degrees freedom for this model? Yes, 0. That's it. This is a 0. That's why we have the 0 degrees freedom shown here. Degrees freedom 0. Why do we have 0? That's how, by using the formula. Okay. So again, okay. So the number of information, let me just write it down here. P, then the
So if the
value.
number of information and the parameters are the same, it'll always be 0 then.
Yeah.
Okay.
Yeah, number of parameters and the number of information is the same, then the degrees freedom will be 0
Yes,
because
ma'am.
nothing left. So it's called a saturated model. You have already used all the information. Okay, so here number of observed variables P equals 2, and the number of information is P times P plus 1 divided by 2. So 2 times 3 divided by 2 is 3. And then number of parameters, in that case, we have 3 parameters. We have beta, we have variance of X, we have variance of the residual part, we have 3. So what is the degrees freedom? This number minus this number, this number minus this number, 3 minus 3, it's 0. So that's why we have 0 degrees freedom. Okay. Any question? Any question? Oh, okay. So yeah, that's the answer to that questions. Any question? And we will have another example. Suppose we have multiple regression. We're gonna use this same formula to do the calculation. Okay, so let's have a break. We have already finished the first example. Next part, we will have multiple regression example. We just finished a simple linear regression. We will have multiple regression in the next session. Now it's 7:15. So let's have a break for 15 minutes, and then we're gonna continue the multiple regression example. Yes. Oh, okay, so let me see what's the error message. Is that-
Oh, shit, I need this one.
So run an example, simple linear regression. Let's move forward to multiple regression. Okay, so now let's look at the scenario. Let's look at the statement or data set. We have this is quite a famous data set called National Longitudinal Survey of Youth, okay, from 1974 cohort. And I just get a small sample from the whole data set. Suppose the sample size, okay, I got a small sample size 371. And include the families, one variable name is called the mother's education level. Okay. We call it ME. ME is for mother's education level. And also we have variable in the data set called home environment. Okay, HE, home environment. And another column is called children's mathematical achievement. Okay, we have math. So 3 variables, ME, mother's education level, HE, home environment, kids, math achievement. And here we have hypothesis. We're trying to set a model like this. Mother's education and the home environment together gonna predict children's mathematical achievement. That's one model. That's just one hypothesis. Okay, so ME, mother's education, and HE, home environment, cause or influence the children's math achievement score. So that's our model. So this actually tells us a multiple regression model. That's it. This is a multiple regression model. Mother's education level, home environment together influence the kids' math achievement score. And for HE and ME, we don't know which one influence which one. So we just put a double-headed here to say that, okay, these two are correlated, but there's no single-headed arrow. I don't know if mother's education influence the home environment or home environment causes ME. It's just double-headed arrow. These are correlated, but these two together gonna influence the kids' math achievement. For this model, how many parameters? We're gonna estimate this coefficient, okay, B1. The coefficient from home environment to math achievement, that's one parameter. The coefficient from ME to math achievement, the mother's education level gonna influence math achievement, which is B2. What is a B2 value? Okay, the standard error, the P value. And then the variance of HE, variance of home environment, variance of mother's education level, covariance between home environment and mother's education level. And then the variance of the residual of math achievement, because this is a dependent variable. For dependent variable, usually we have the residual term, okay? Y equals A plus X, A times X1 plus the B times X2, and the residual part. Usually we have a residual part, and we use a simplified version. The residual part, just use a double-headed arrow here, okay? This is a variance of the residual of math achievement, S3. So we have S1, S2, S3, 3 variance, 1 covariance, and 2 coefficients. In this model, we have 6 parameters. We're trying to estimate the 6 parameters, okay? 1, 2, and we have 3 variance and 1 covariance. That's our model. Now let's try to use the data to do the data analysis. So in ELC, you're gonna download the file called rdata.txt. Okay, it's for R and it's TXT, just very, it's very just a plain, it's no format, free format data file, 3 columns. The first column ME, mother's education level, and the second column HE, home environment, the third column math achievement, kids achievement, 3 columns only. We also have the header of the table. Okay, so we have the first row shows the MEHE math. And starting from the second row, we have the actual value. So this is the first student's record, the second student's record. So we have 371 rows without the header row, okay, without the head. So following the 4 steps, the first step, make your data ready. You're gonna import your data into R. Of course, you're gonna use library. So library SEM is ready. So if you done the previous step, you don't need to repeat it again, okay? Because the SEM is already there. And then you're gonna tell the R, where's your data? So you can set up your working directory, just we reviewed in the previous week. Or you can manually click, okay, session and set working directory, choose your folder. You can run here. Of course, this is my folder, it's not your folder, okay? If you have your own local folder, you're gonna finish part here. You're gonna modify the path here. Okay, some folder and some disk or something like that. And then this is a text file, okay, TXT file. We're gonna use read.table to import the data to R. So read.table and the file. The file, it should be located here in this folder because this is my working directory folder, okay. So the file is saved here and then I directly put the name here, the data file name here. And the first row is the header. So I included the header of the table. So header equals true. Otherwise, yeah, they just mistakes. They think that the first row is the numbers, and that's not good. And I save all of this data set called NLSS, National Longitudinal Survey of Youth. This is my name. This is the name of the data set in R. You can try to print the data file to see it. So if we go to R, yeah,
I have a question.
yeah.
So if we're more comfortable with using M+, would there be an alternative?
Next time we will talk about M+. Yeah, I just teach you all the available software, and you're gonna pick. Okay. If you think R is good, if you think M+ is good, or yeah, you can just pick the best software. Yeah. Okay, so here, if you want to try to change the session, so click the session here, the set working directly, and we have some options. So the final one is choose directly. So I'm gonna choose my own directly. So where I save my data file. So that's it. This is my folder, and click open. And that's okay. This is my folder, and you can also change something here. You can also modify the path here. Okay. It's the same thing. And then I'm gonna read the table. I'm gonna use a read table to import the R data.txt. So I highlight this part, click around, it's ready. So now NLSY is ready for you to use. If you want to check, you can just check the data file here. All of these are students or participants inside the data file. Okay, so you have 3 columns. Again, this is not the column inside your data file. This is just provided by R. Okay, this is R information. So the first column ME, the second column HE, the third column kids math achievement. 3 columns. And actually, it omitted some rows because the file has 371. You can check. You can use N rows to see how many students participants here. So you can just use this in the function. So totally we have 371 rows. Although here it shows you 303, but actually they deleted some. They didn't show the rest part of your data file. Or you can use head, okay, just like we reviewed previously. MLS head just tell you the beginning part of the data set. Beginning part of your, oh, it's already here, okay. Yeah, it's already here. So the first 6 students' records are shown here. Now the second step, you're gonna calculate the covariance matrix of your data. How? Just use COV, covariance matrix of your data file. That's it. You create the S. S now is totally based on your data, no model involved. Just do the COV, okay? And then you can check the S here. That's it. This is your covariance matrix of your data set. You have ME, HE, math, 3 variables. So the covariance matrix is 3 by 3. This one is a variance of ME. This one is a variance of HE. This one is a variance of math. And the covariance between ME and HE, covariance between, this is variance of HE. This is the covariance between ME and math, covariance between the HE and the math. And this is the variance of math. This is a sample-based covariance matrix. The second step is ready. Now the third step you're gonna show your model in R. Okay, you're gonna tell R what is your model. So let's go back to slides. I have the detailed. Yeah, this is a sample size. Also sample size, you can use n row. N row tells you the n sample size. S is a confidence matrix. Now we're gonna use specify model to translate the path diagram here to the R code. And again, 3 components for each parameter. So as we counted, we have 6 parameters. We need to estimate 6. So here we have 6 lines. Suppose the first one, okay, the B1. I want to estimate the B1. What is the path B1? Is from HE to math. Okay, so here, HE goes to math. That is the direction. The name is B1. Starting value, I don't want to specify any starting value. I will let the system to decide the starting value for me. So that complete the first parameter command. Okay, so that's for B1. We also have B2. B2 is a second parameter from ME to math. Okay, then from ME goes to math. This is the direction. This is the name B2. We call it a B2. Starting value, I don't want to specify any. And then, yeah, we have S1, S2, S3. So yeah, the order doesn't matter. The order inside the block here doesn't matter. So S2 is HE, variance of HE. So HE double-headed arrow because it's variance, same name, okay, variance of HE. We call it the name of this parameter is S2, okay, S2. Starting value, no. And S1 is for ME, okay, so ME to ME, double-headed, ME to ME, double-headed, variance of ME. I call it S1, starting value, no. Covariance between SE and the ME. So HE, ME, double-headed covariance because the names are different. We use S12, okay, S12, and starting value, no. And then the residual part, S3, okay, math to math, although it's a residual part, but we just assume it's a simplified version. Okay, from math to math, double-headed arrow here, and S3, and starting value, an A. That's it. We have 6 lines. Give the specific parameters, the 6 parameters here. Okay, describe, give the description of the 6 parameters here. Next part is trying to estimate these 6 parameters. What is B1 value? What is B2 value? What is S1, S2, S3 covariance between ME and HE? And then finally, the power sign to finish all of this model. This tells us the model, multiple regression. That's it. That's third step. 4th step, just do the estimation. The function name, SEM. 3 components. The model, sample-based covariance matrix, sample size. Sample size, capital N. The S, we describe it here. Okay. Multiple regression. This is the name of this model. Multiple regression is the name of our multiple regression model. So 3 components. That's it. Done. Okay. Let's go to RStudio. And we can try to, yeah, this is our RStudio. So we have multiple regression. This is that. We have B1, B2, S1, S2, S3, covariance between HE and ME. Highlight this block together, okay, and then run it together. Yeah, we have already done this part earlier. So run SEM, 3 components, and then we save the results to model 2, multiple regression. Okay, this is just my name. Okay, you can just change it to other names. I just call it model 2. Actually, it's a multiple regression. Okay, And remember that if you put a dot between the letters, it's still okay because this is a name of an object. Right? So highlight this part, you can try to look at the results. Okay. That's it. This is a result for the object. Of course, it's simplified version. If you want to see more, we have a lot of like a summary or another functions to do that. B1 estimated here, B2, S2, S1, S3, covariance, chi-square, degrees of freedom. Okay, so let's just look at the detailed information. Look at the summary of the result. Okay, so summary. This is large. Let's run again. Okay, here we have chi-square value, degrees freedom. Again, we are going to calculate the degrees freedom again. Why it's 0? Okay, and yeah, later on we will see what's the chi-square model chi-square value, how to calculate that. Yes, BIC, we will also talk about this later. And normalize the residual. And R square, and here, this table is very important. Parameter estimates, B1, B2, S1, S2, S3, S1, 2. Estimate, point estimate, standard error part, Z value here, probability. Again, all of these are very small, okay? All of these are very small because you have to move the decimal point 3 digits ahead, 3 positions ahead to make this number tiny. And here, it tells you the meaning of that parameter. Okay, B1 is from HE to math. That is a coefficient of home environment influence on the kids' math achievement. This B2 is a coefficient of mother's education level, okay, influence on the math achievement. And the variance of HE, variance of ME, and the residual and the covariance among them. All of these results are shown here. Okay, so that's the next one. So let's look at the slides. We have, yeah, this is our sample. This is a sample based on covariance matrix. This is a model. The SEM software automatically calculates a model-based covariance matrix for us based on our model. So that's the output here. Yeah, so the beginning part, this is a data set. The data set here. Output. The symbol output when you run the SEM. And this is the summary output. The summary. This table is very important to give the estimate of each parameter and their significance, their p-values. And again, let's try to do the calculation of the degrees freedom in this case. Now we have different scenarios. We have different case. Oh yeah, actually we can just use this information here. First, what is a p-value? What is a number of observed variable in this model? What is a p-value? Observed variables. HE, ME, math. 3. What is the number of information? What is the number of information?
6, isn't it?
What is the formula? It's P times P plus 1 divided by 2. Yes? Yeah. 3, 4, 6. Now, how many parameters in this model? How many parameters in this model? He said 3. 3. 6, which 3, which 6? Which 3?
Oh, if you're counting all the other ones, then it would be 6. correct?
Yeah, 6. We have B1, we have
B2,
B1, B2, S1, S2, S3,
S12.
covariance. So totally we have
Right.
6. Now what's the degree freedom for this model? Exactly
0.
6 minus 6. This 6 is the number of information. This 6 is the number of parameters.
0.
Nothing left. So what does that mean? We cannot estimate actual parameter. That's it. 6 parameter at most. This model can at the most estimate 6 parameters. I cannot estimate the 7th or 8th or 9th. Okay, so that's the degree freedom. Okay, that's correct because in the output it says that degree freedom is 0. 0. Okay, 0. Actually, we have already finished the second example, multiple regression. But if you look at the code, I have more code for you. Yeah, now let's look at another. This is a lab, we can do some exercise. Let's look at this model. This part keeps the same, but look at B1. Look at B1. Look at this part. I changed the code a little bit. I said, HE goes to math, NA0. What does that mean? This is a different interpretation. Okay, so I want to set the home environment. So there's a statement. Okay, I assume the home environment will not influence kids' math achievement. NA, I don't want to estimate that parameter because that parameter has been set 0. That coefficient is assumed to be 0. The influence of the home environment on kids' math achievement is 0. In that case, this is not. In that case, the model here, the model home environment will not influence the. Let me just.
Do you need another marker?
That's okay. Yeah, I think of the. Yeah, it's not very strong. I assume the home environment will not influence kids' math achievement. So the coefficient here, B1, has been set 0. There's no influence. That is a statement. If we have that model, then we're gonna set our model like this. The name of the parameter is NA. NA means not available. No parameter is available. What is the value of that parameter? 0. Okay. 0. You assume this is 0. And of course, the other part is the same. Okay. And here, and we're gonna estimate the B2. B2 is there. And we have the variance part, covariance part. Now, in this case, let me ask you, how many parameters we are going to estimate for this model? How many parameters? 5. Why? Why 5?
You're not estimating.
Yeah, B1 is skipped. We don't need to estimate B1, so we only have 5 parameters. Now let me ask you, what is the degree freedom for this model? 1, exactly. We only have 1 piece of information available, so we have actual information available because we don't need to estimate the 6 parameters. So you can try to replace the model by using this code. Okay, you can highlight this part and run again And then go back to estimate, go back to run the estimate. Okay. Yeah, so now, yeah, this part is the same. This part is the same. We use M2. This is M2. This is called M2. Okay, M2. And the S is the same S. Okay, same S here. We calculate the sample correct images. Same sample size 371. Let's try to run this part. And it's very simple. Degrees freedom. Now let's look at the degrees freedom. It's 1. Now let's look at the parameter estimate. B2, S2, S1, S1, 2, S3. No B1. No B1. B1 is skipped for this model. Yeah. Yeah, this is another alternative model. And you can try to look at the summary for second model. Summary, we have level again. Yeah, we have degrees freedom is 1 here. And we have the parameter estimates. These are our parameters. B2, starting from B2, no B1. And the estimate here, standard error here, Z value here, P value here.
I got an error on mine when I ran that.
Which part? You got an error part?
Yeah, on this new version 2. It's fine. We can look at it after
Error.
class. I just don't understand why I got an error on that.
Yeah, that's weird.
It's a parameter error.
So if you goes to the previous part, is there any error starting from the previous?
No.
Okay. Okay, then
That's
that's
fine. I'll
okay.
play
That's
with it.
okay. Yeah.
I'll play with it and
Yeah.
see if I can figure it out.
Now you can try to run the model like this. And you can also try to look at this. Actually, we also have a lab for you. So after we finish today's for R, next week is for M+, EQS, and AMOS. After we introduce all of these softwares, we will have a lab time, and you can just do the game here. You can manipulate all of these models. This is another model. For this model, I try to estimate B1 here. Okay, let me make it darker. I try to estimate B1, but for B2, I don't want, for this model, I assume that mother's education level will not influence the students, the kids' math achievement. Oh, no, I was wrong. It's fixed at 1. So that means mother's education level will influence math achievement, and that value is fixed at 1. So influence is fixed. It's not 0. If it's 0, that means it's not no influence, but it's 1. It's constantly influenced. Okay, and it's not a parameter. I don't want to estimate that one. It's a fixed at 1. And the other part keeps the same. And same thing, this model, we only needed to estimate 5 parameters. Okay, so without B2 here, B2 is fixed. And then again, if you run it again, the degrees freedom will be 1 because you have 1 extra available information. Okay. And you can try to highlight that and do the estimation. Yeah. Okay, so in this case, we have B1 estimated without B2. B2 is fixed, and then we have S1, S2, S1, 2, all the estimated value here. Here, I give you some fit indexes. We will cover this part later on. These are called the model fit indexes. All of these indexes tells us if it's a good model or not. Okay, I haven't explained each of that. We will do that next time. Let's look at this model. Okay, if I give you like this code, what does that mean? So this is M4 specified model. Okay, HE goes to math, ME goes to math. Look at this. I use the same variable name, B1, B1. What does that mean? In this model, I assume B1 and B2 are exactly the same. These two. So models, education, and home environment will be exactly same. The inference, the coefficients are the same, and the reciprocal is the same. Again, here we only estimate 5 parameters.
So if you change, instead, if you get rid of B2, you would have to redraw your model to show B1 going from both home environment and ME if you were to display that, like draw out your model. You would have to rewrite those.
These tell us different model.
Okay.
Yeah.
Yes,
I just give you the code directly,
sure.
but actually this code means
Right. I was just trying
Yeah.
to visualize the
Yeah.
model that you had. up
you're
top.
right. These two are exactly
Yes.
the same. Yeah. So
Okay,
in this model, we assume that these two coefficients
is both
are,
B1.
yeah, B1.
Okay,
Here, this is a tricky part. You can give a same name to assume these are the exact same. Of course, you can use B2 or you can use B100. It doesn't matter. But you have to make sure these two names are the same. Okay. Okay, this is one path. And these two paths are exactly the same. These two paths.
I was just trying to visualize that and make sure I
Yeah,
was
you're
following
right.
what the code was saying.
You're
in
right.
my
These
head.
two paths are
Okay.
assumed to be the same. Yeah.
Thank you. Sorry for
And
interrupting.
yeah, you can also give 100, B100. It's the same. In R, if you give that, that means it's equal. So you can also try to run this part. And look at this. What's the degrees freedom? In this case, yeah, it's still 1. It's still 1. It's still 1. And we have the B1 and B2 are together. So it didn't provide you the second row. It just gives you one parameter. For B2, for the other path, it's the same as this one. Okay. Estimate here, send error here, here, and all of this. And later on, we're gonna do the comparison among all of these models. I just provide you some possible models, but which one is the good? Which one is the best to describe the data here? We're gonna use model fit indexes. Yeah, some assumption is not reasonable because we just, for example, we just assume that the B1 is 0. That is not a good assumption. So the model fit indexes will immediately tell us, no, that model is not good. You're gonna change your model because that assumption is not reasonable. And you can also compare different models. Okay, for example, some two models are quite close to each other. Then which one is better? The simpler the better. Okay, so if you have two quite similar models, just pick the similar model because the number of parameters is smaller. Is that better? But if you have significantly different models, then just pick the model with a better model fit indexes. Okay, yeah. We will talk about all of this later on. Yeah, we have some other alternative models. We have model 5 here. This is our last model. So what does that mean? So look at the code. We have, okay, that's also a very interesting model. Do you understand the meaning? So now I give you a paragraph, the part of code, and if you understand the language, actually the computer language is kind of like a language. They're trying to tell you some information here. Okay, so what's the information? What's the model here? Do you understand what's the meaning of this model, of this code? So we have, oh, it's here. Actually, it's here. So let me just note this. ME S1. This one is S1. HE S2. This one is S2. Math S3. Okay, now let's look at this part. HE S1 2. S1 2. Now let's look at ME double-headed math S1 3. ME S1 3. HE math double-headed S2 3. That's it. This is our model. What is this model?
A nightmare.
This just tell us, okay, all these three variables are correlated. There's no single headed error. I don't know.
I was sitting there trying to figure out how to do the path analysis with all those double-headed arrows.
Yeah, all of these are correlated, and we're trying to get the covariance among them and the variance among them. But there's no clear pattern. If HE gonna influence on the math or not, I don't know, because there's no single headed error. If the ME gonna influence the math achievement, I don't know. It didn't tell us. That's the model. The model here actually is kind of like a. Actually, there's no model. It just tells us, okay, please calculate the variance of three variables, the covariance among these three variables. There's no actual model. Then you can also try to look at that and just see what's the result. Okay, again, what's the number of parameter in this case? What's the number of parameter? 6. Yeah, still 6. The degree freedom is still 0. We don't have any available information. Because freedom is still 0. We have already used all the information here. So we have S1, S2, S3. Okay, 3 covariance. These are variance part. These are covariance part. All the information are estimated here. So is this a good model or not? It's not a model. It's just description. It's just described all the available variance and covariances. Okay. We will also go back to this model again. Okay. So for M+, we will do some comparison models. Okay. So this is one of the comparison models. They also have independent model. Okay. So we will introduce more models in the next topic about the model fit indexes. That's it. That's for today's lab. Actually, it's just introduction of the R package for the SEM. And
Introduction. Felt like I was drinking out of a fire hose.
yeah, so next time we will continue to introduce those SEM software, especially we're gonna focus on M+, we're gonna focus on EQS and Amos. Amos is not available here, so Amos is not available on the desktop here. But I will just give you the slides. I will give you the procedures. And if you have your software, you can do the exercise of the class. Okay. Okay, that's it. That's for today's class. We don't have any homework yet. Next time, after next class, we will have homework 3. Okay. Yeah, question? Okay, good. And if you have any question about your homework 2, okay, graded homework 2, about my grade, please let me know, okay? And we can talk about that.
Bye.
Bye.